Hello everyone, welcome to my video. In this video, we'll continue our journey in Chapter 1. I will cover Section 1.5, 1.6, and 1.7. Section 1.5 deals with gravitation. We'll start with this famous gravitation equation that you should be familiar with, F equals to G times m1, m2 over r squared, where F is the mutual force of attraction between two particles, or it's the weight, right? It's a force, can be either in Newton or pounds, is a vector, and it's subject to change. We'll see that next slide. And G is the universal constant known as a constant of gravitation. Here, the 6.673 times 10 to the power of negative 11 is in SI unit. As a practice, you should try to convert the G to its imperial units as a practice. M1, M2 is the masses of two particles or objects, and R is the distance between the center of the particles. Right? Remember, it's a center between particles, because sometimes if you're dealing with the Earth, the object is too large to assume it's a particle. Right? So it's the center to center. Let's look at a simple example of how altitude can affect the weight. Note, I'm not going to say the mass is changing, because mass is not changing. The weight is the one changing that we're talking about here. Suppose we have an object placed on Earth's surface, and by drawing the free body diagram, we can see that there are two forces acting on the object. Using the gravitation equation, we can calculate the gravitational force at this time is based on the Earth radius, 6,371 kilometers. We can calculate the gravitational force is 9.8 Newton. That is about 2 pounds, assuming our object is 1 kilometers. Then I'm going to raise the same object to a much higher altitude, 12,742 kilometers. Can anyone guess where that is? Either way, using the gravitation equation again, subbing the new distance, we can calculate the gravitational force again. This has been reduced to 2.4 newtons. This is about half a pound. If you are open to a grocery store in the space, you probably want to think about to raise the unit price for those products selling by weight. So acceleration near surface or near Earth's surface has a special name called gravity. We all know that. And this is derived by using the gravitational equation based on a free body diagram that we derived on the previous page. And you can see here, gravity is independent of the mass of the object. However, you can see from the example on the previous page, it can change with altitude or change with r, the distance between two objects. Through mathematical operations, we're able to derive an equation to calculate the gravity at different altitude given. So let's take a look here. At the Earth's surface, we have G naught, it's G times Earth over the Earth radius, and at altitude h, our distance on the denominator changed from r to r plus h, is center to center distance, remember? So you don't need to do it over and over again, start from scratch to recalculate the gravity at altitude h. Given the equation G equals to G naught times r squared over r plus h squared, we can calculate the G at any given altitude. And G naught is we call the absolute acceleration of gravity at sea level, and h is altitude above surface of the Earth. R is a constant, is the radius of the Earth. Unfortunately for us who need to use the gravity in our calculation all the time, gravity can also change with latitude. This is due to Earth's rotation and its shape. I just said unfortunately, but on the other hand, fortunately, there is a standard value of G we can use for the most of the time. SI unit, that is 9.81. Imperial unit, that is 32.2. If we are dealing with near-surface scenarios, we can use those standard values. If you're interested, you should find out more about how gravity can change with the latitude by yourself. I'm not going to spend too much time, dive too deep here in about changing with latitude at this time. Lastly, dimensions. I believe you should have gone through this in statics, but let's review it anyway. You can think dimension is a bigger category or a higher category above unit. With the same dimension, you can have different measurements, right? You can measure length in millimeters, in centimeters, in meters, in kilometers. And different dimensions cannot be added or combined in any way, such as adding 5 centimeters with $20. What does it even mean? Lastly, the dimensional analysis. Although we're not going to deal with this concept in this course, this is a method can be used to check homogeneity of relations and equations. You will learn this in fluid dynamics course. Here, I'm just mentioning it to build some foundations for you. In your textbook, you will find about a full page talks about this method of TAC. I extracted some core steps here, and you can read it. I'm not going to read it here. You can pause the video. I appreciate its value, especially for new learners. However, I want to mention that this is a general procedure. Right? It might not be the optimum path of solving a problem, but it provides a thorough procedure and a guide to check everything. Following those procedures, that guarantees you won't miss anything. That's the key. Over the years, after doing so many questions myself and seeing so many students work, I sort of developed my own ways of doing things. And you'll see that during classes. Again, just like the previous slide, this is a general procedure. As long as you develop a good habit that suits you the best, right? You can show all the steps and thoughts, then get the right answer. That's what matters. And for those 8 steps listed here, sometimes you just don't need them all. Again, this is why I made this video, so we can spend more time in class to see how to solve different problems using different methods. Do more examples, as you asked. Asked by those students who took this course before you. So feedbacks do matter. From time to time, you would like to ask how to get marks or how to get more marks. So here, my number 1 recommendation is come to class. Right? Assignments and exams are going to be designed based on what we did, what we said in class. Do your assignments, do the project report early. Give yourself plenty of time. Don't wait until the last minute. Right? So you have time to check your answer, check your steps, make sure you get the right one. And meet with your instructor and TAs. We're here to help you for anything. Exam strategies. I will have 1 dedicated review session for the midterm and 2 for the final exam. So we'll talk more about exam strategies by then. So this concludes our Chapter 1. Unit 1 should be a review for most of you. This is also a chance for you to see where you are. If you understand everything quickly, great. If you had some trouble at some point about anything, please do something. Either review some concepts, do some basic practice problems to refresh your memories, or you can reach out to me if you need any specific guidance. Thank you for watching. I'll see you next time.